Hello guys, so welcome to our fourth week now, almost a month. So here we start lecture 7, okay? We will continue in examples about solving circuits with diodes, our new element that we discovered, okay? And here we have two diodes in series, but different from the last examples, they are, in opposite directions. I mean, this guy is basically, if we check its connectivity to this battery, it's reverse, and this guy is forward. So let's verify this more. So the inside of this guy is close to the positive of the battery, and its B is closer to the negative of the battery. So this guy is just reverse, which is diode 1. And diode 2 here, its B is close to the positive, its N close to the negative, so it's forward. We can make it in another way. Let's say that this battery will give a current in that way. Basically, batteries, since if you have one battery in your circuit, if you have just one battery, so either there is no current at all, either I equal to 0, or the current is going from its positive terminal to circulate in the circuit and go back to its negative terminal. It cannot be the opposite. Okay, if you have one battery, okay, then you have either two situations. Either you don't have current at all, current is equal to 0, or if you have a current, it must be in that way, going out of the positive terminal, circulate back to the negative terminal. In that case, the current is going in that way. Okay, and when you see a current going in the N side, going out of N side, then the diode is reverse. And when you see, which is diode 1 here, and when you see a current going into the B side of a diode and going out of the N side, this is forward. So diode 2 is forward here. Okay, we have many, many ways to do it. Or maybe you can say the following, the third one here. So basically, this is a ground, and this terminal here is connected to the positive terminal of the battery. So this is the highest voltage. This node is the highest voltage in the circuit, and this N here is connected to the highest voltages in the circuit. So basically, B, this side here, has less voltage for sure. So it's reverse. While this guy, its N is connected to the lowest voltage in the circuit, which is the ground. So for basically the B side should have higher voltage. Okay, good. In that circuit, these two diodes are matched. So this is mentioned here. It has a meaning. Okay, and this V input is fixed equal to 5 volts. Matched diodes or matched transistors or matched any two element, whatever, means that they are, identical. They are identical. I mean, same geometry, same material, silicon, same characteristics, same, everything is the same. But you can connect them in different ways, like what we have here. One of them is forward, one of them is reverse. Okay, so they might have different voltages. Of course, in that circuit here, they are in series, so they must have same current as well. Okay. Now it's required to find the voltages and the currents. I'm sorry, the voltages, okay, and the number B, the currents, in two cases. First, when V breakdown is less than V breakdown equal to 6 volt, and the number 2, when VBD is equal to 4 volt. In two cases. So let's start by the first one. When VBD equal to 6 volt. Good. We know for sure that D1 is reverse, D2 is forward, and they are identical diodes. So what we're gonna do here? Good. So let's go back and check the characteristics. Of course, both are matched diodes, so they have the same characteristics. So we have just one characteristic here and ID/VD. This ID can be ID1, VD1, or ID2, VD2, because basically they are matched. They have the same characteristics as well. Okay, they will be different in the operating point. Okay, one of them in the forward region, the other one in the reverse region. Okay, good. So let's start by the reverse one, which is D1. D1 is reverse. Okay, so it might be here, or here, or here. It might be region 1, in which VD1 is much less, or VD1, yes, much less than VT, or comparable to VT. It might be in 2. At that case, we know for sure the current. It will be equal to minus IS, or saturation current. Or it might be in region 3, which is the breakdown. And in that case, we will know for sure the voltage. It will be equal to minus V breakdown. Okay, so which one of these is closer to us? Okay, if we assumed it's in region 1, still everything will be, unknown for us, because it might be here, the operating point, or here. You don't know any point here. You have infinite points. So, but if we assume we are working in region 2, then you know for sure the current at that time. Okay, so in that case, it's better to assume 2. But someone may ask why we didn't assume it's in 3. Just look at the input. So the input is 5 volts, and the breakdown is 6 volts. And again, as I said last lecture, for a diode to go into breakdown, it needs the source, the battery of the circuit, to give the diode its required V breakdown. So basically the input is 5 volts. It's less than the V breakdown. So we can say this. Since V breakdown is larger than or greater than V input, which is 5 volts, then for sure D1, which is reverse right now, is not in breakdown. So we have either region 1 or region 2, for sure. Okay, so if it was not in region 2, it will be in region 1, for sure. Also, if it was not in region 1, it will be in region 2, also for sure. So basically we assume 1, and if we are wrong, we will be for sure in the other one. If we assume it's in 1 and we prove it's correct, then it's correct, and it's not in 2. But if we assume it's in 1 and it was not correct, then we are for sure in 2. And the opposite is also correct. If we assume it's in 2 and we prove it's correct, then it's really in 2. If we assume it's in 2 but we prove it's not in 2, the assumption is correct, then it will be for sure in 1. Okay. But the easier thing here is to assume it's in 2, because if we assume it's in 2, we know for sure the current, it will be IS. So assume that D2 in region 2. That means D1 here. D1 is as a magnitude much larger than VT, and ID1 equal to minus IS. Good. Just look at the circuit now. Okay. Just look at the circuit. What is the relation between ID1 and ID2? So ID1 here is going from bottom to up, and ID2 is going from up to bottom, top to bottom. So ID1 is minus ID2. So ID1 will be, let's remove ID2 and both minus IS. So minus will be positive. This will be IS. And what is ID1? ID1 is equal to IS. Remember, both diodes are matched. They have the same IS. Matched means IS1 equal to IS2 equal to IS exponential VD2, I'm sorry, over VT minus 1. Okay, let's write this in a neat way. So IS equal to IS exponential VD2 VT minus 1. This will go with this, so this will be equal to 1. So exponential VD2 over VT minus 1 equal to 1. So this will give us exponential VD2 over VT equal to 2. Take len or logarithmic for base 2 for both for basic for base the natural number I'm sorry. So take len for both sides. So this will give us VD2 equal to VT, which is 26 millivolt, len 2. This is 26 millivolt. So if we calculate this, this will be 18 millivolt. Good. So now we know ID1, we know ID2. Look at this. They are in series. They have same current, but since one is bottom to up and the other one in the opposite direction, they are minus each other. And we know now VD2. Now we can calculate VD1. Just look at Kirchhoff here. So from KVL, Kirchhoff voltage law, let's see the directions. So this guy is upward from negative to positive. This guy is downward from N to B or negative to positive. This guy is, so V input plus VD1 minus VD2 equal to 0. So we can say that a VD1 is equal to minus V input plus VD2 equal to V input is 5, so we have here minus 5. And this is remember 18 millivolt, not 18 volt. That's a common mistake. Remember to convert from millivolt to volt. It's minus, I'm sorry, 0.18 volt. So this gives us VD1 equal to, let me check my solution here. Yeah, minus 4.982 volt. As the magnitude is much larger VT. Okay, so the moment of truth now, when we calculate ID1, okay, it's equal to IS exponential minus 4.982 divided by 0.01026, 26 millivolt minus 1. This, if you do it in your calculator, this will give you minus IS, because this is basically approximately 0. Okay. Another verification here, we said that it's not in breakdown. So the magnitude of VD2, VD1, I'm sorry, should be less than 6. And this is also less than, as the magnitude, VD1, less than 6. So we have two checks here. Okay. So that's basically number A. So let's now do number 2. And number 2, V breakdown is 4 volt, which is less than the input, which is 5. Remember, in number 1, or point A or point 1, we exclude that assumption that D1 is in breakdown because the input 5 volt was less than the breakdown voltage. But now, no. Now we can't say that D1 is not in breakdown. It might be, but it's a possibility because now the breakdown is less than 5 volt. So it might be now in region 1, region 2, region 3. Okay? But again, based on the facts that we learned from 1, we can from the first time assume the correct assumption from the first time. Okay, so let's see how. From 1, we discovered that VD1 is equal to minus 4.9, or so its magnitude is greater than 4. Its magnitude is greater than 4. And at that time, the input was 5 and breakdown was 6. So that means if the breakdown is less than, as a magnitude less than 4.9, so with that input, we should go, or D1 should go to breakdown. Okay, so let's write this. So from point 1, VD1 was minus 4.982, and this magnitude is less than, greater than 4 volts. So it is now, we can say highly probable that D1 is in breakdown. And again, it's not harming to assume something and disprove it if it's correct or right, So let's assume it's in breakdown. Let's assume D1 is in breakdown. Since it's in breakdown, then you can say for sure that VD1 equal to 4 volt, minus 4 volt. Because if we are in reverse, the voltage is negative. Minus 4 volt. Now you know V input, you know VD1, you can know VD2 because Kirchhoff is a fact. Kirchhoff working all the time. So we can know VD2 from that equation. Let's call it equation 1. So from 1, equation 1, VD2 is equal to V input plus VD1. 5 minus 4 is 1 volt. Can we determine now I1? Yes, or ID1? Yes, because in number 2, it gives us the saturation current, 10 to the power minus 17. Okay, so ID2 equal to IS2, or IS, let's call it IS because both are matched, exponential VD2 over VT minus 1. So let's do it this on the calculator now. So this will give us, this is 10 to the minus 17, and this bracket here will give us 5.05 10 to the power minus 10 to the power 16. So ID2 is equal to 0.505 amperes. And remember, this is equal to minus ID1. Just look at the circuit here. This is going from up to down. This is going, ID1 is going from down to up. So they minus each other. Okay. So this is equal to amperes. Okay. Now the checks. We want to know if we are right or wrong. Okay, let's look at the characteristics. If we are in breakdown, okay, I should be as a magnitude greater than IS. Look, if we are working in here, this is greater than IS. If we are working in here, this is greater than IS, and so on. So this is basically ID1. Check here. As a magnitude is much greater than IS. IS is 10 to the power minus 17. And look here, this is half amperes. Okay, now let's do something, very insightful here. Okay, now we finish the solution of this problem. But for number 2, let's say that you have some doubt about this solution because maybe the other, you want to be sure that really the other assumptions are wrong. Okay. So I'll assume that D1 is in region 2. And it's not in breakdown. And we'll disprove that, or we prove that this is incorrect. So let's do that on a side here. So with another color. Again, we finish this solution. This is just for your, understanding. Let's assume here that D1 is not breakdown and D1 is in region 2. So IS or ID1 equal to minus IS. And the VD1 should be much greater than VT. Okay. So ID2 will be equal to minus ID1 will be equal to IS. So IS or ID1, which is IS, equal to IS exponential or e to the power VD2 over VT minus 1. So from that, VD1 will be equal to 18 millivolt, because this is basically what we have done in the first one. Okay, I'm just repeating it. So I know this will give us 18 millivolt. So sorry, this is D2, here is 2, and here is 2. I'm very sorry for this. Okay. Now from Kirchhoff, VD1, if we look at back, because we are doing the same steps exactly, will be minus 4.982. Is this right? No, that's incorrect, because VD1 here as a magnitude is greater than 4 volts, which is a breakdown. And we see in our assumptions that D1 is not in breakdown. But now, and it's not in breakdown, that means VD should be less than 4. It's more than 4. So the assumption is not correct. Okay, guys. So that's basically another, very good example. Okay, and stay tuned for other videos, because we're gonna take other examples on the diode as well. Okay, thank you very much and see you.